It turns out that panelizing PC boards for assembly is way harder than it looks. So that's what we're going to take a look at today. Welcome back to Cloud 42. I'm James. Or maybe it'd be more appropriate for you to welcome me back. I've been gone for a few weeks working on some other projects. Turns out I had a whole bunch of packages to ship. Who knew? And I've also been getting things ready for a couple of future projects in the shop. I have now ordered the parts to put a 3 horsepower high-speed spindle in my CNC mill. So you can be looking forward to that project coming up in the future. But today I want to talk about panelizing PC boards. For the uninitiated, when you manufacture a lot of PC boards, especially a lot of small PC boards, there's some advantage to panelizing them. And that just involves taking a bunch of small boards and then putting them into a larger panel for manufacturing purposes, so that instead of having to handle all of the individual boards, you can manufacture the entire panel and then clip or snap out the individual boards. Makes things more efficient. And sometimes it reduces cost, though that's not always the case depending on the fab that you're using. This is a video that Dave Jones did now 9 years ago talking about panelizing PC boards, and he's got some others. Here's one for his microcurrent product where he talks through some of the details. Now, Dave's videos are great. I highly recommend them. The challenge is he's using commercial software like Altium Designer that costs real money, and for hobbyists, that's kind of out of reach for most of us. So I was trying to figure out how to do this with open source tools, and I spent a lot of time and went down a lot of dead ends before I finally got it to work. And I thought I would put together a video today just to show how to do it so that you can skip some of that learning curve. And along the way, I developed some software that I'll be sharing here today that makes it a little bit easier. This is the board that we want to panelize. This is the electronic lead screw PC board that I've been selling. I have made quite a few of these, and I'm looking at this point to make the manufacturing a little bit more efficient, so I want to put these into a panel. I'm doing this work in Circuit Maker. There are other tools that you could use. There are commercial tools. There's other free tools like KiCad that are entirely appropriate for this. I happened to use Circuit Maker because it was free and because I've done some other PC boards in here in the past. I've used Eagle in the past, but Eagle is no longer free for commercial use. If you actually want to do anything in Eagle and have it be sold, you can't use the free version. So there's a few things that we need to set up in here in order to make the panelization process easier. Let me flip back here to 2D view. One of the things is down here in the corner, you see this mark. And this little circle with the X in it marks the relative origin of the board. And I want that set on the lower left corner so that I know that that lower left corner will be the 0, 0 position in the generated files. And the way you do that is on the Home tab, you just come over here on the right to Origins and Jumps, Set, and then you get crosshairs and you can set that wherever you want. So I just clicked here and it sets the relative origin on that corner. The other thing that I did is for the panelization program to work, you have to have the board outline in the Keep Out layer. So over here, I've selected the Keep Out layer and I've drawn a line just using the line tool around the perimeter edge of the board. I already had a line on the outline layer, and that'll work fine if you're just making one board, but the panelizer tool that I'm using wants it on the Keep Out layer. So I selected the Keep Out layer and drew this purple line around the edge of the board. That's real simple, and I actually have it on the Keep Out and the outline layer. It doesn't matter as long as you have it on the Keep Out layer. This process will work. Now, in order to have this board manufactured, there are a few things we need. We need to generate some Gerber files that describe the PC board so that it can be manufactured by the CNC machines and the optical machines that manufacture the board. We also then need to generate a bill of materials or a BOM that lists the parts that go on the board, and we need to have a pick and place file or a Centroid file that shows where those parts are located on the board. Now, to make this easy, I have gone into the schematic, and on every one of these components, like this Q1 component right here, I have added a new parameter, which is the LCSC part number. LCSC is the part supplier that JLC PCB uses. In fact, I think it's actually the same company, and their part numbers are the values that are actually used in order to uniquely identify the parts that they place. So by coming into every component here in the schematic and actually adding an LCSC part number as a parameter, that will allow me to export it in the BOM, which will then allow them to select the part automatically so that I don't have to go in and select them all individually when I order the boards. You can also take the components that you use, put them in your favorites, and generate updated versions of those components that have the part numbers already on them. So to generate the output files, you can come in here to outputs, you can generate pick and place files, you can generate Gerber files, you can generate your numerical control drill files. You can do all this separately, but it's generally a lot easier to just release the project. So if you come up here under project and click release, first thing it'll want you to do is save the file and commit it. And we'll go through that process here. And then we get the dialog to configure the project release. First thing we want to look at here is the bill of materials, and we want to configure this file to have the fields that we want, and you can configure those down the left. We do not need, let's see, I've already been in here and fixed some of this. So you've got the description, the designator, the footprint. I've turned off everything else. I've selected LCSC part number, which is that part number property that we added to all the components. And then the last one here is quantity. We don't actually need that. We just need these 4 columns. And then we need to select comma separated values, so a comma delimited field. Now you can actually generate this as an Excel spreadsheet, but that won't work with the panelization tools that I wrote, so we'll just leave this set to CSV. Next thing we need here are Gerber files. Now you can go to the JLC PCB website and they have screenshots of all these dialogues showing how they want all of these things set. Generally it's just the defaults. Over here on the Advanced tab, though, I want something set that they don't show, and that's the position on film. I want to set that to reference to relative origin. And the reason for that is I want 0, 0 to be located at this relative origin that I set. Otherwise, this is by default at 1000, 1000 mils. And so then that throws all of your values off when you start dealing with board coordinates later, and it's way easier to keep track of everything if you just have it referenced to the corner of the board. And then the other thing on the Gerber files is you do need on the layers tab to make sure you are generating the GKO, which is the keep out layer that has that board outline on it. Next is the NC drill files. Make sure this is turned on. And we also on coordinate positions want to reference to relative origin. Same thing there. Then we need generate pick and place. Turn that on and configure it. I want that to be a CSV file. This is an Imperial board, so Imperial is fine. Everything here is being output in mils, which are thousandths of an inch. I've never tried anything else. I have no idea if JLC PCB supports metric boards, but we'll stick with what we know. And I think that's all. There's some other stuff in here you can generate. Then just click release. And what it'll do is it'll run through and it'll generate all of these artifacts, put them into a zip file, and then upload those to the website. Now that's done. We have a release summary, and we can go download the files from CircuitMaker.com. Okay, I've just logged into CircuitMaker. Go look at My Projects, open up this project, and we scroll down here, and here are the releases. I'm going to go ahead and delete that one because I didn't really want the new one, but we'll take a look at one that I did here a couple of days ago. The date's wrong. I did not do that in 1969. This is the Lee's Group Booster Pack, and the last one was 1A12, and we'll just download that file. Okay, here's the file downloaded. Open this up, and let's just go ahead and extract all the files out of the zip. And this is what it generates. It's going to released, and we have a bunch of things in here. We've got the Gerber files in one directory. We've got the numeric control drill files in another. Now I'm just going to copy these, put those over into the Gerber directory because that's where we're going to want them all. Then I will grab all of those Gerber files and I will zip those up. And there we have a zip file containing all of our Gerbers. So those should be ready to go. So let's look at the other files that were generated here. Down in the BOM directory, we have the bill of materials, and that looks like this. It just has it's a comma separated value file that has exactly what we said to put in it. First, the description. In this case, it's two designators C1 and C2. There's the footprint, and there's the part number. Now, in reality, the fab is going to need these, C1 and C2, so it can go look those up on the Centroid file and know where to put them. And this tells it which part number to actually place in that location. The other file in here is the pick and place file. That's here. And this is what that looks like. We've got the designator, so R13 needs to be placed at a location mid X and Y of 500 mils and 350 mils with a rotation of 90 degrees on the top layer T. And so every component that needs to be placed has all these coordinates in this file. So that's all we need if we wanted to make a single board, but what if we want to make an entire panel? To generate the panel, we're going to need a few tools. To actually panelize the PC board, the Gerbers themselves, we're going to use the This Is Not Rocket Science Gerber tools. These have been featured all over the internet, and this is sort of the de facto open source standard for creating PC board panels. It's not super fancy, but it does the job, and it does the job well as long as you stay within its capabilities. So we're going to download that, click over here on Releases, and a link to this will be in the description. And I'm going to download the gerbertools.zip. The other thing that you're going to need to handle the BOM and the pick and place files is a piece of software that I put together over the last few days called the Cloud42 PCB tools. And there's a BOM panelizer tool in here. This is something, again, you can do this stuff by hand, but it's a real pain. And I don't know about you, when I do things by hand, I make mistakes and waste a lot of time. So I wrote some tools to make this easier. And we'll go in here, there's one release, and I'm just going to download the one PCB tools zip file. Now with those downloaded, we'll just unzip them both here in our working directory, extract all. And extract all. Okay, those are the tools ready to go. Let's start with the panelizer. So I go into Gerber Tools, into Panelizer, and just run this gerberpanelizer.exe. And we'll open this up. And the way this tool works, the UI is a little sketchy and it's got some issues. So we'll start with File New, and this will create a new board. And then we can go in here to Panel Properties and set it up. Now I'm going to go ahead and just set it up bigger than I need, say 300 by 300, margin between boards. I'm going to try to be smart here and say 2.54 millimeters, so that'll be 100 mils. Fill offset for empty area. I don't know what all the rest of this stuff does, but this right here, clip to board outlines, is important. In my particular board, I have a couple of scenarios here where some of the silkscreen lines actually go off the edge of the board because this was a part of the footprint of a part. This is a connector I wanted to have hanging over the edge. So if you come in here and actually clip to the board outline, their Gerber generator gets really, really confused. And because I have some of these solid areas where I've got an outline around the outside of a white block with an outline around text inside, it's important to understand which part is inside and which part is outside so it knows which part is solid. And for whatever reason, if you have things overlapping the edge of the board and you let it try to clip them, everything goes crazy and the silkscreen turns into a snowstorm and stuff like my logo down here turns inside out and it is ugly. So if you have anything overlapping the edge, definitely turn off clip to board outlines. That's all the settings we need. And then the next thing we need to do is just bring things in. So I'll go back up here and go to my Gerber files. I've got my zip. I'll just drag that in and drop it. Now that's dropped an instance of my board here on the panel, and you can see the little plus mark here in the lower left corner. And that's because we set the relative origin when we did the export of the Gerbers. If we hadn't done that, that little X would be down here, and it would be trying to position the boards based on that coordinate. So the one in the lower left corner goes off into negative coordinates, and everything gets really, really weird. Now, there's a couple of things you can do in here automatically. So you can go up here to board placement and say AutoPack Naive, and it'll just throw it down there in the corner. Now I can come over here to my Gerbers that I just inserted here. I can say add an instance. It'll make a second instance, which has now appeared someplace like up here where you can't see it. Board placement, AutoPack Naive, and it drops it down where you can see it. Now I could just say, okay, I want to go ahead and generate a bunch of these, add instance, and then it explodes. So this is one of the things I've discovered is you really have to place every board after you bring it in. So I will just go ahead and continue here, file new, and repeat this process. So I bring in my Gerbers and board placement, AutoPack Naive. Now, of course, I made the panel too small. Let's go ahead and make the width 200. And just keep adding my instances, and in between say AutoPack Naive, add instance, AutoPack Naive, we'll just throw in 4 of these. And that's how you get through this process without killing it. The next thing you need to do is add your break tabs. So I can just put my cursor where I want one, right click and say add break tab, and it'll add a break tab in that location. So I can go through and add these. You can see the text turning green. I assume that's telling you that the board has enough support. Now, I want to do something a little bit more complicated than this. You can see I can move these around and place them by hand, but they're not perfectly centered. They're not perfectly consistent. You can select these individually and come over here and enter your X and Y coordinates. And I went ahead and put a spreadsheet together. Now this is in millimeters, but the actual locations where the boards are going to land is actually in mils, because these are nice even numbers, 1675 mils high, 2300 mils wide with 100 mil spacing, since I set the board spacing to 2.54 millimeters. And I wanted to edit this stuff by hand. So what you can do is you can come in here when you're done and say File, Save As, and save a file that you can use to save your design for the panel. Now, I actually created one of those already, and I have that here. It's stored as a Gerber set file. And if you open this up and take a look at what's in here, it's just an XML file showing the PC boards that are imported into the panel and then where they're located. So here's an instance centered at 0,9. Here's another instance set at 0,54. These are all in millimeters. And these are all the instances of my board. And then I actually have a panel strip for the bottom and a panel strip for the top. And I have those imported as separate, and I have the locations all in here. Then you have the break tabs. This one's located 11 millimeters X, 97.9 Y. And I came in and generated all of these and edited them by hand to get them exactly where I wanted. I created an Excel spreadsheet to figure out all the coordinates. And this is what I came up with. So you can just say open, and I can go find my Gerber set. So this is the panel I came up with. I've got a separate PC board that's a panel strip for the bottom that just has a little bit of text on it, and another panel strip for the top that has, again, some identifying text and a location where I want the fab to put their part number, and then all of the break tabs for all the boards. The reason I wanted the strips is so that the fab can put their tooling holes in these strips, and they can put their part number on the strip so they don't end up on the boards. And I also wanted to have a nice smooth edge to make it easier for the panel handling equipment that's used for assembly. So once I have this, I can then just do an export. So export merged Gerbers. Make a new folder for this. And export. And this export process may take a little while, especially if you have a complex board or if you have lots of them like I do here. And this will just grind and it'll create the Gerber files for you. And now that it's finished exporting, it has popped up a couple of PNG files showing the preview of the front side and the back side of the board. And you can see it's generated these little mouse bite tabs with drill holes in them to make them easy to break at those locations. Now, I think I've got enough support here to make the panel rigid enough to manufacture. We'll find out what it's actually like when I get the first ones back from the fab. But in this direction, I've got double mouse bites tabs on every board to try to make it rigid, because I assume they're going to handle it by these strips on the edges. And then in the X direction, I've only got single tabs in there, but the overall rigidity should be fine because of these lengthwise strips. We'll see how that all works out. This all looks good to me. So now we need to worry about the part placement. This just generates the files to manufacture the board. We can actually go look at those that were produced. They're here in this Gerber's directory in the panel. Let me go ahead and make a zip from that. So these are the panel Gerbers. Okay, now that we have those as a zip, let's take a look and make sure it all looks good. This is Pentalogic's ViewMate. This is their free viewer software. You can download that. There'll be a link in the description, and I'll just bring in the zip file here. Click OK. And there is our board. There's our panel. So this looks good. I have the outline layer. Let me turn that off. And so then you can see the keep out layer, which is this. Turning it off, turning it on, which shows the routing around the outside of the board and the routing around all of these internal slots. And this all looks fine to me. So now let's go take a look at part placement. As we discussed earlier, the actual assembly is controlled by the bill of materials and the pick and place file. So the bill of materials, we need to essentially increase the quantities. So right here, like if we look at here, C1 and C2, those are both this one particular part. But we no longer have just 2 that need to be placed. Since we have 12 instances of the board, we need 24 of these. And they all have to have unique identifiers. So for the first board, we would normally do this as like C101. For the second board, it'll be C201. For the third board, it'll be C301, and so on. And so we need to expand all of these lists to show unique instances of the components for every board in the panel. Then for the pick and place file, we have the same kind of thing. So let's find those again. Here's C1 and C2 down here. So C1 is at a particular location, 630 mils by 950 mils. Well, we need 12 instances of C1. So we'll need C101, C201, C301, all the way up through C1201 for the 12th board in the panel, with all of these coordinates offset to the correct location. Now, you could do all of this by hand, but it gets really complicated to get straight, especially since every one of these lines needs to become 12 lines, and you need to add the correct offsets to all of these coordinates. And that itself is not easy, because it's not a simple matter of the first board being at 0, 0, because it's not at 0, 0. It's actually offset because of this bottom strip. So this is where the custom software I developed comes in. I wrote my own PCB tools, specifically a BOM panelizer, so you can give it the BOM file and the pick and place file, also called a centroid file, that shows where the center or the centroid of the components are all placed, and a description of your panel, and it will expand them for you. So I've already done that for this particular panel. I have my panel description. It's also a CSV file, and there's a sample here. There's also a sample one in the GitHub project that you can just copy and modify for your needs. So this has got a line for every board in the panel and the designator base and the location. So in this case, for components starting with 100, those are located at coordinate 0 mil by 355 mil. So that's the X and Y coordinates of the lower left corner of the first panel. So here's board 200. The offset 200 is at this location. Then 300. I don't know why these are out of order. I must have been smoking something when I did that. And then 400, 5, 6, 7, 8, all the way up through offset of 1200. So what it's going to do is it's going to take every single component and it's going to offset it. If you've got R1, it's going to make an R1001 all the way up through an R of 1201. And it's going to modify the coordinates accordingly. Okay, I have a command line open to my working directory here. Do a dir, and I have my PCB tools directory here. And change directory into that. And there's a few things that are in here. I've got the BOM Panelizer jar. This tool is written in Java. And so all of the code is actually in a jar file. You need to have Java installed on your system. It's Java 1.8. And as long as you have a runtime, a JRE installed, and it's in your path, you should be able to run this. And then there is a batch file that actually runs it so that you don't have to type the Java command line. So I can just say bompanelizer.bat. And again, error, unable to access charge. Oh, okay. So I just found a defect. I will fix this shortly. Because there is a space in the path of my directory, I have to have quotes around this. Try that again. There we go. So you just run bompanelizer.bat, and it shows you what options you have to provide. You have to provide the BOM file, the bill of materials, the Centroid file, which is the pick and place, an output directory where you want the files to go, and the panel definition file. That's the CSV file that I just showed. So I can actually run this. I just go back up to the parent directory here, and PCB tools, BOM Panelizer. I need to give it the options that it wants. So minus B. There's the BOM file. Minus C. There's the pick and place file. That's the Centroid file. Minus O output directory is called panel right here. And then minus P, my panel file, which is my panel description.csv. So it is a complex command line. I apologize for that, but there will be documentation on the GitHub page. But for now, just the output of the command here tells you what to do. I will hit enter, and just that fast, it will actually generate it. So it took these input files and generated an output BOM file in the panel directory and a pick and place file also in the panel directory. So we can go look at those. So in here with the Gerbers, I have a BOM. I'll bring that up here and we'll take a look at it. And you can see that what it's done is it's expanded it. Instead of just C1 and C2, we have C101, C102, 301, 302, 201, 202, and in fact, there are 24 instances of that if you go all the way across. For some of the other things, like the transistors, there were 6. Now we've got 101, 102, all the way up to 301 through 306, 201 through 206, and again, all of the instances are expanded out in the bill of materials. And if we look at the pick and place file, that's been expanded as well. So here's R13 is what it started at. Now we've got R113, 313, 213, 413, 513, and it has offset the X and Y coordinates. And this output should look just like the input file. The tool does a lot of smart things about trying to figure out which column in here is which. It's looking for a designator column, and it's looking for columns that end in a space X and space Y. So mid X, mid Y, ref X, ref Y, pad X, pad Y. It's converting all of those. Everything else is just passing through without modifying. So you can see that the Centroid file has now gotten much, much, much larger. And that's it. We now have a Gerber file that we can upload to the board house, and we now have a complete BOM and a complete pick and place file. Let's upload them to the JLC website and see what happens. Okay, this is the JLC PCB website, and we'll just click on Order Now and try out the files. So add your Gerber file, and I will go to the ones that I just generated, not the ones I did yesterday. Go into Panel here, and here's my Gerber's zip file. Let that upload. It's a complex Gerber, so it takes it a minute to think through it and generate the preview. And there's the preview of the top and bottom sides of the board. Now you can see in the preview, they're actually not showing the routed slots. Makes me a little bit nervous. I suspect this is just an issue with the preview tool or with their Gerber viewer, and that it ultimately is going to be okay, because if I open it in the Gerber viewer, it does actually show the slots routed. Now, it doesn't properly show all the things here, like with my logo. It gets confused about what's inside and outside on these inverse text pieces. You can see this part of the silkscreen is off onto the tab because it didn't clip. In general, though, this looks all right, though there are some weird things down here as well with some of these pads. I'm just going to ignore that and assume that those are issues with the preview. Because, again, I've seen weird things with the preview, but then when the boards come, they're just fine. Let's pick some ridiculous number. Let's say we wanted 50 panels, which would be, 600 boards? I definitely want lead-free. Since I put my little JLC, 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 JLC text up here, that's where I want them to put their part number. And so I'm going to say specify order number yes, so that they will look for that and put their part number on the tab rather than on the boards themselves. And I'll click and say I want to assemble. I want to assemble the top side, and I'll let them add the tooling holes. Confirm. And the next thing it wants is a BOM file and a CPL file. So the BOM file, here's the combined BOM file we generated. And the CPL, or the pick and place, or the Centroid file is this one. Upload those, click next. Now they're going to give us a listing of the BOM. And again, here's like all the transistors all listed out. And they've expanded this out. I gave them the file with the expanded list so you can see all of the individual components, and there are a lot of them. And over here, you can see that these are all marked confirmed. Normally what happens when you come in here with just a normal PCB layout is this will say unconfirmed, or it'll say confirm and it won't be checked. The reason it's done that, and normally then what you have to do is you have to come see the part that they've matched, or if they couldn't find one, you got to go search for a part from their inventory and decide which part that's supposed to be. In my case, because I included the LCSC part number, they were able to find them exactly, and they came in here pre-confirmed. So those are all ready. I will just click next. And there's the preview showing the part placement. So we can zoom in. Again, their preview is a little wonky here. But here's the first board, and you can see all of the parts placed. There's a voltage regulator. These are LEDs. You see the plus and minus. Those are in the correct orientation. Now, you note these transistors are actually shown here upside down. Now, I'm a little bit confused because if I go back to boards I've ordered before, those I'm using the same part orientation, and and they looked fine in the preview before, but if I upload exactly the same files I used before, they're now showing them upside down. So this could be an issue in the preview, or it might be an issue where the preview is previously wrong and these parts are actually oriented incorrectly. I'm not really sure. I've seen other videos where people talk about JLC's PC board ordering, and they say, yeah, don't worry about that, they'll fix it for you. And that might be true. Before I actually did a production order, I went back and changed the orientation of those in the pick and place file. It said 270 and I just changed it to 90, so that flipped it 180 degrees, and so the preview looked right, and we'll see what happens when the boards arrive. So you can look through all 12 instances and you can see that those components are all in the right place and in the right orientation except for those transistors, and that is just because I used that tool and expanded out the BOM. So this looks pretty good. I think this is ready to go, and actually those are irritating me, so I'm going to change the orientation on those. So I'll just come back up here, and on my single here I will open up the pick and place file. And I will go in here and find my Qs. There's 270. I'm just going to change that to 90 on all 6 transistors. One, two, three, four, five, 6. Save that. And you can go back and go through all the work of rotating the footprint in Circuit Maker, but I'm not going to rerun this. Okay, that's done. Now let's go back to the website and go through the ordering process again and take a look. And that's better. With the orientation fix, you can see those transistors are now pointed the right direction. And like I said, I don't know if that was a preview problem or not. At least this way, if I have some kind of an issue and they don't get soldered or something weird happens, I can point back to this preview and say, nah, the preview looked good, so the problem's on your end. So I don't know if that's really an issue. Like I said, every board I've ever sent to them, even when this thing's been under development and the preview's been completely broken, and the components didn't show up at all, I've still gotten functional boards back from them. So I'm pretty sure they've got somebody looking at every single board and verifying and adjusting the rotation. Again, some other YouTube shield reviewers have pointed that out and said that that's how that's supposed to work. Now, I am not getting anything from JLC PCB. I just use them, and I'm paying full price for all of their services. Honestly, if they wanted to contact me and give me some kind of a kickback for doing the thing I was going to do already, I would think about it, but that's not currently happening. They've never contacted me. So, this is just a service that I use, and I've been real happy with it. But yeah, no, they don't pay me anything. Maybe I should fix that and try to make some money off of this, but I haven't. So I think that's it. The software is up on GitHub now. I will fix that issue with the quotes in the batch file. I think this stuff will work on Linux, though I haven't tried it. If you try it and have an issue, just drop an issue in the GitHub project. I'll look at it. I also haven't tried it with metric files. I think if you just put in millimeters, the code will handle it properly and do the output in millimeters, and you just put everything in millimeters, it'll be fine. If you try it and it doesn't work, let me know, and I will take a look at it. Now, I have put in an order for 10 of these panels, and when they come, I will do another video and show the results. Honestly, I don't have a ton of confidence in the JLC PCB previews. I've ordered, in the time that their assembly service has been up, I've probably placed 6 orders in the last 2 months from them, and every single one of them has had some new unique problem that I've run into in the UI. Either it was broken completely and the previews didn't show up, or the previews showed up with no parts, or the part orientation was weird, or the parts were shown off the side of the board, or any number of issues. Every time there's been something different wrong with the website. They're evolving this pretty quickly. But when I've contacted customer support, in each case, they've told me, don't worry about it, just go ahead and submit the order, we'll check it by hand. And in every case, the product that I've gotten in the end was good. And I am doing 100% testing on these, so I'm not too worried about defects in the boards. But, like I said, the service has been okay up to this point. But it always makes me nervous, which is why I only ordered 10 panels. I don't want to go crazy and be sitting on a whole bunch of boards that don't have internal routing or, something weird like that. In any case, when I get the panels, I will do another video and show the process of breaking them apart. We'll take a look at what we got, and we'll see how this worked out. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.